Hey, Nix people. We're going to continue our journey through Chapter 4 of Eelco Dolstra's PhD thesis named The Purely Functional Software Deployment Model today. In the last video, we went over Section 4.1, which was named Motivation, and Section 4.2, which was named Syntax, and we're going to move to Section 4.3, named Semantics. I think it's going to be kind of tough going here because you got a bunch of equations in here. I am not going to slow down for those too much because I don't really want to spend the time unwinding them. But I think we can get some value out of the descriptions of the equations anyway. We have basic values. We talked about numbers, strings, paths, and URIs described in the syntax part of this thing. Then we also have null values as the built-in nullary function. Null booleans denoted as a built-in nullary function, true and false. Nullary functions are just functions that accept no arguments. Don't care about parsing. Don't care. Subpaths are a somewhat obscure language feature that allows files in a derivation to be referenced from other derivations. So you can say something, if Perl here is a derivation, you can say Perl tilde bin Perl, not in quotes. Yeah, you can omit the quotes. And so that is the same as saying Perl.outPath plus, in quotes, bin Perl. I don't think I've actually ever seen that used. Perl.outPath here, that's the derivation path of Perl, output derivation path. All path values are internally in canonical form. They're not relative to the current directory. They don't contain a dot or dot. No redundant separators, they're abs pathed. It talks about compound values, lists or attribute sets, recursive attribute sets. We already talked about that stuff. We see that attribute values can be inherited from the surrounding lexical scope through this inherit thing here. We talked about that before. It's just syntactic sugar. This syntax I had seen before, but I didn't quite really understand it. So if you say inherit and then in parens some attribute set, and then two identifiers, two names, it desugars to, if you say AS1 in paren, then XY, it desugars to AS1.X and AS1.Y. And then there's some complication about that for attribute sets that are recursive, but the intent is the same, and he just says there's some special magic to make it work. So this substitution stuff, I'm just going to skip over this because it's pretty in the weeds, and I don't think it's worth the time unwinding all this. Basically, it's a computer language. They have variables. I'm sure it's more complicated than that, but I'm not going to spend the time to unwind all that. Evaluation rules. This is all computer science flexing here. Uninteresting. Attribute sets, sub-attributes from attribute set. We're selecting a, attribute set dot something. Only interesting bit here is that if you say attribute set dot something and something doesn't exist, it's an error. There's probably something interesting here about let that I don't. Attribute body from a recursive set of attributes. There's probably something interesting here that I can't be bothered to unwind at the moment. I'm sorry, folks. There's probably something that's not just flexing there that is important to understand. I apologize for being a pussy. With two kind of function calls to single argument functions, i.e. lambdas, or just plain beta reduction and lambda calculus. And then there's another kind of function call that accepts an attribute set, but then binds the values that are in the attribute set to the local scope of the function body. And there's an expression, there's a equation to denote such a thing. I think what I just said is enough to understand the language. I'm not all that interested in the formalisms here. We have conditionals. We must evaluate to a Boolean, and it fails if it's not a Boolean. Evaluation fails if it's not a Boolean, huh? Okay. The condition then evaluates to one of its alternatives. Does that mean that it fails? If it fails, it does the else part? If okay, let's say, do we have a derivation here? This should be, yeah. If derivation, then one, else two. Okay, no, it just fails. It just doesn't go on. Okay. This is unlike Lots of other languages like Python. So there are things like truthy. Assertions. Assert 0. Boolean. Assert false. Okay. Zeros are not booleans, huh? Integers 1 and 0 are not booleans. Okay. True. I don't think that. Okay. Yeah. Okay. Okay. See, so 1 and 0 are not substitutable for true and false, and the right hand of that is returned on that assertion. Got it. With expressions. Unexpected. Oh, yeah. I gotcha. Mm-hmm. Yeah. Okay. Operators. Equality operators. 1 equal 1. True. False. 1. Can you do that here? Nope. 1 equal. Can you compare these two? Yeah. Okay. And then we have not equal. Okay. Fair enough. Boolean operators straightforward, although it's worth noting that conjunction and disjunction and or are lazy, shortcutted. Okay, so and or here. So yeah, okay, so we say 1 and 2. Oh, true. Yeah, sorry, booleans. False. True or false? That's true. True and false is false. And that means that if I did false, the shortcutting here is that if the left-hand side is is false, then the right-hand side isn't even evaluated. So it doesn't really matter. As a matter of fact, I wonder if I can even, I wonder if it'll, yeah, it doesn't even bother. This will give an error, I bet. Yep. Okay. Yep, it's not even evaluated. Update operator. 2 attribute sets can be merged or the right biased union. So that means the values in the right attribute set override the values in the left attribute set in the result. And it comes up with a new attribute set. Oh, of course it's a semicolon. Yeah, of course it's a semicolon. Yep. So, right. Yep. Addition is between strings and paths. So we can say 1 plus 2 is 3, but we can also say foo plus bar. Plus bar. That. But they have to be in quotes. Yep. Otherwise they're considered identifiers, right? Yep. And then there's question mark to track set membership. So, I mean, well, what happens here if I do this? Okay, you don't need the F. What you do need, what? What? I don't, what? Really? Okay, well, I'm smarter now. I don't like it, but I'm smarter. I really don't like it. I don't like that at all. Okay, I'll get over it. Primitive operations, props, are functions that are built into the language. They can be overridden by local definitions. The most important primitive operation, the raison d'etre for the Nix expression language is the primop derivation. What is relevant here is that instantiate down here, talk about the equation, takes a set of attributes, translates them to store derivation, returns an identical set of attributes, but with 3 attributes added. The attribute type with a string derivation, the attributes derv path and out path containing the store path, so the store derivation and its output respectively. So intuitively, derivation just calls instantiate. But it doesn't actually just call instantiate. We want derivations to be very lazy. The expense of calling instantiate should only be made if we actually need derv path and out path. For this reason, derivation postpones the computation of those attributes by using an indirection such that unless the derv path or out path attributes are evaluated, it takes much less time to do that. This is the laziness bit. Next primap is import. Unary operation import p reads a file, p parses an Nix expression, applies certain checks, and evaluates and returns the expression. The validity checks are expression that must be closed. The requirement that imported expressions are closed is rather important. It implies that a no imported expression can refer to the local scope of the caller. So if you import something that it has a unbound variable in it, it's not going to look up the call stack to resolve that variable. It has to be closed within the thing that's being imported. Also, any relative path constants currently in the expression are absolutized. P needs, okay, so P is the path. If the path denotes a directory, the path /default Nix is automatically appended. So the astute reader will know the load expert depends on the contents of the file system. That is, it depends on some mapping of past the file system contents. This mapping is left implicit in the evaluation rules. And importantly, it may also appear to make the evaluation calculus impure, implying that equational reasoning no longer holds. I don't know what the fuck equational reasoning is, but for instance, it might appear that import P is equal to import P does not always evaluate to true because of chronology. If you do import P here, a second call to import P, the file P has changed. They might not be equal. But because of maximal laziness, which we talked about before, this is not in fact the case. You only evaluate import P once for a given P. And interestingly, I noticed this in other in other languages, like I'm a Python programmer. If I edit a Python file after I've let's say I'm developing some software and I fire up a process that uses my Python stuff, there's a very, very small amount of time where that Python is being evaluated by the interpreter. So basically, I could fire up the process and then 200 milliseconds later or something like that, I would be able to edit the file, and the changes that I make to the file would not be reflected in the process that's being started or has already started, or however you want to think about it. Not so much in Nix because it may be several minutes before something is evaluated due to this laziness stuff. So, you fire up NixOS rebuild, and then let's say you see some bug or something, or you want to add a package or something like that. It might add that package on the currently running NixOS rebuild because it hasn't imported that file yet. So I think that's why that happens. And then apparently you can import a derivation. I guess we'll see about that later. It's not just files you can import. It's not just Nix files you can import. You can import .drv files, so store derivation. And I guess that sort of makes sense because store derivations are really just attribute sets. So, right. I don't know why that's useful. I guess we'll find out later. And finally, the null primops true, false, and null are constant symbols. They represent themselves, have no evaluation rules. There's also an ever-growing set of utility functions added in an admittedly ad hoc fashion. Oh, yes, definitely. Such as map, base name of, and so on. Not relevant to this discussion of the foundations of Nix expression language. They unfortunately are very relevant in actually using it. They are quite haphazard. 4.4 implementation. So he talks about maximal laziness again. This is the property of an expression. When an expression is evaluated, it is only evaluated once. The result of that evaluation is cached, and whenever it's evaluated again, that result comes back. And then there's a bunch of discussion about the caching and black holing. that can detect certain kinds of infinite recursion. Well, I guess that's sort of like a negative cache of some kind. I'm uninterested at this point. I'm sorry. I'm sorry if you are interested, and you'd not be wrong to be interested. I'm not interested though. Sorry. Expression casting scheme described here makes the Nix expression evaluator maximally lazy. Maximal laziness means that syntactically identical items are evaluated at most once. Backtraces. The Nix expression evaluation fails where we import a syntactically or otherwise invalid Nix expression. A backtrace is printed of the evaluation stack to give the user some clue as to the cause of the problem. It gives an example here of a backtrace. It says backtraces in lazy language are tricky as a failing value may be finally evaluated in a piece of code far removed from where the value was produced. Yeah, if you've been using Nix for a while, you know this is true. Because things are evaluated lazily, it's hard to provide anything in a human consumable order, and it also might seem to skip frames. And he just sort of throws up his hands down here. He says trace may not show every pertinent code location, and it may not show them in equal order, but the locations that it does give usually give enough of a clue to figure out the cause of the problem. So he's saying, yeah, it sucks, it's terrible. There's nothing I can do about it. This is another reason that once people do start to use Nix, and they get an error, the errors are often unhelpful, very long. They're not in any particularly good order. Yeah, and they often what will happen is it'll seem like all the entire backtrace consists of the framework code that called your code, but it has no references to your code in it whatsoever. It's all this frameworky shit that happens. That happens quite a bit, and you just kind of gotta just suck it up and guess a lot of times. At least that's what I've had to do. I'm sure there's more scientific ways to do it, and I'm sure if I used it for longer and wrote a lot more Nix, that I would have some more tricks. But currently, my go-to is to scour the backtrace for code that I wrote, which isn't always easy. It's often at the beginning or in the middle or whatever, if it's there at all. And then just kind of try to divine, guess, what it might be complaining about. And sometimes it's syntaxy and it's easy, and sometimes it is semantic and it's hard. So, okay, so he talks about optimizing substitution here. I don't really give a shit about this. I couldn't care less. I don't even understand. Reducing, I'm sure. I apologize to people who do care about this. This is just nonsense to me. I don't really care about the internals of the language. Okay, so my apologies. That was pretty tough. My 2 years of college, of being a journalism major at college, don't help me much there. This isn't Eelco's fault. This stuff came in later, but in certain attribute sets, you can say imports equal and then a name of paths, and it was a sequence paths, a list of paths, and when you do that, it is evaluated by something that is not described in this PhD thesis. That is some add-on that someone came up with later, and it's kind of unfortunate that it wasn't anticipated by the thesis, because that thing is really super fucking magical. Because not only it's not like it is not the equivalent of import path with an empty attribute set, as the calling argument for each one of the paths that's listed in there. It does something else, and it's super unclear what it actually does. I presume that it scans scope, the enclosing scope and its enclosing scope and its enclosing scope for everything that might match the names that are in the function arguments, and fills them in. It's like a magical apply. And I haven't actually found that described anywhere. And it's pretty important to understanding how Nix works that you understand what it's actually doing, because it's really, really super magical. It's not, yeah, I'm sure someone will point me at it, and I'm sure I can go read about it. But wow, yeah, I wish it was part of this thesis. I wish it was part of the original understanding of it, but it is not. And it seems to have been added later. And yeah, it's hard to describe to people. I'm also, my mind is also broken by the fact that we haven't quite got to, and I can't tell whether this is actually machinery of Nix itself or of Nix packages, but my mind is getting broken by the fact that we haven't quite got to how, when multiple attribute sets are merged, that represent, like environment system packages or something like that. There's also no mention of sort of the syntax here, where you can either say foo.bar.baz equals something, or foo equals, open curly bar equals open curly, baz equal open curly, whatever. No mention of that so far. I don't think we're going to get to it. I'm not sure. Sort of hard to tell, because the following chapters are mostly about sort of the store, and maybe we'll get there. But I think that might also be a feature of Nix packages. Oh man, yeah, that is tough. That is tough, dude. Because what it means is that you couldn't even just hand somebody this PhD thesis and tell them to read it. Not that they would anyway, but. Yeah, so as presuming that you got past that, then you have to figure out, okay, like that's something you have to figure out, you have to know. And then there's this other thing where there's this notional, global attribute set, at least that's the way I think about it, of stuff like environment.system packages of configuration options. That stuff all appears to be a feature of Nix packages, not Nix itself. The thing that makes sense out of the values that are in all the attribute sets, and then sort of merges them together to form, the quote unquote what I want, is not really part of Nix. The thing that does it from multiple files, it's not really part of Nix. It's Nix packages. So these are all the things that make Nix very, 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 very difficult to understand and learn, because they're not all part of one thing. They're split across these things. Very tricky. All right. Thanks for watching.